Hello, everyone, and welcome to this webinar. I believe this is the fourth webinar in the SHERPA series. And my name is Patel. I work for F-Secure Corporation. Just a little bit about this webinar. I'll take questions at the end. So if you have questions, something comes up that you want to ask about, just feel free to type them as I go, and then I'll address them at the end of this presentation. Just a bit of a background on SHERPA. So SHERPA is an EU Horizon 2020 project, whose aim is to study ethical and societal impacts of AI. F-Secure is a partner in that project, and we have been looking at this study from a technical perspective, from a cybersecurity perspective, in order to evaluate the risks that AI may impose on our security. We wrote a document about our research in this area, which we published about this time last year. And this talk covers some of that document. Unfortunately, I don't have time to cover the whole thing, but I have updated the facts a little bit since it is a year old, and lots of things have happened since then. This field moves very fast. My talk will be broken into three main areas: what can go wrong with AI, how AI can be attacked, and how AI might be used for malicious purposes. And just a bit of a background on what we mean by AI. What we actually mean is machine learning. So traditional software is composed by people writing code. So you have an input, you write some code, which will then generate the output that you want. And your operating system that you booted your computer from, the web browser that you're running, and the software itself that's showing you the webinar, this is all created in this way, in this traditional way. But machine learning, you have inputs and outputs, and you train an algorithm to transform the input into the output. And a trained algorithm, an algorithm that's trained in this manner is often called a model. So when you hear me talking about models, actually what I'm talking about is a trained algorithm. And the reason that we use machine learning is to generate algorithms that would be difficult to write by hand. For instance, it would be very difficult to handwrite code to recognize a dog in a photo or convert speech to text, and so on and so forth. And in fact, there are many applications for this now. I'm not going to read through these. You're probably familiar with some of these things already. When you think about like image recognition, Google Translate, some various game playing, self-driving cars, things like this. So onto our first section, which is about what can go wrong with AI. And I've broken it down into four main categories. So the first one is that the model architecture or parameters are incorrect. There are many different model architectures available in machine learning, and each of those has many parameters. As an example, I have spent the last 2 or 3 weeks trying to train some agents to perform simple tasks in a virtual environment. I've tried dozens of different algorithms. I've tried for each one dozens of different parameters, and I still haven't gotten anything to work. And every time I try it, of course, it takes at least a few hours to see whether it works or not. So this is a difficult thing to get right. The second thing that can go wrong is that the input features are irrelevant or introduce bias. I will show some examples of this. Third thing that could go wrong is that you train your model with insufficient data. So you collect a data set, you train a model, and it looks like it outputs accurately what you want. But then when you put it into production and it sees real world data, it sees data that wasn't in the training set. And therefore it will not be able to handle it properly. And the fourth thing that can go wrong is that you're trying to do something that can't be done or shouldn't be done. And we'll show examples of this as well. So my first example involves Twitter bot detectors. And so there are online services where you can input the name of a Twitter account. It'll tell you whether it's a bot or not. And these typically look at the fields that are circled in this picture of Donald Trump's Twitter profile. So it'll look at the name, the description, the location, when the account was created, how many tweets it's published, how many accounts it's following, and how many accounts follows it. And it's not possible to determine whether an account is a bot just based on these fields. What you would need is other things like their tweet history, who they interact with, what time of the day they tweet, how often they tweet, things like this. And then it's still very difficult to determine whether that account is a bot or not. So these services are used by lots of researchers, but unfortunately they're just not accurate. And this is to do with the fact that these inputs are not very relevant to the task at hand. In this example, Amazon built their own in-house AI to rate job applicants. And this in-house AI was trained on data based on their own hiring decisions. So they took CVs and then they rated them based on whether they hired that person or not. And it turned out that this model was rather biased. And it reflected the biases in their historical hiring decisions. So it downgraded women, it highly rated aggressive language, and the resulting model favored candidates whose name was Jared and who played lacrosse. Natural language processing tasks use machine learning nowadays, and one of the things that we do in natural language processing is to create word embeddings. So the way that this works is you take some text, be it news articles, Wikipedia entries, social media posts, forum discussions, so on and so forth, and then you train a model, and that model creates numerical representations of words, and you can then find these word associations that follow the same or have the same relationships. For instance, in this left-hand diagram, you can see that the vector between man and woman is quite similar to between king and queen. So it found those representations, and the same thing for walking, walked, swimming, and swam. However, since these models are trained on real life data, of course they pick up the biases in society. So, for instance, this paper from 2016 found out that word embeddings actually find relationships such as man is to computer programmer as woman is to homemaker. I understand that some schools are nowadays using machine learning models to grade essays. Of course, the way they do this is they feed it essays and the grades that were assigned to those essays by actual teachers. And then the model is meant to automatically grade essays from there on in based on that training data. Of course, this doesn't work because in order for a machine learning model to properly grade an essay, it would need to understand what was written in that essay. And in order to do that, it would have to understand human language and understand about us, the world we live in, how we think, and so on. And we don't have AI at that level. We're not even close to having AI at that level. So this is a model that's doing something that it can't or shouldn't. And in fact, it can be easily defeated. There are these essay generators online where you can give it some keywords. It will generate you an essay, which does really well in these essay grading models. And the reason for that is it's looking for sentence structure, paragraph structure, grammar, the use of certain words, and so on and so forth. And so it outputs these essays that are nonsensical, but they do well on the essay grading algorithms. Here's an example I found recently. It's the only example I've actually seen of this, but it's a model whose results were falsified. So someone caught this and realized that the model itself had a lower accuracy than what was reported. And of course, people might use this model not knowing that the accuracy was falsified and therefore obtain incorrect results. I would expect that there might be other examples of this, but they're just not known yet. Now here's an example of machine learning working the way it should, but perhaps not providing the intended consequences. So in these two cases, Twitter's recommendation algorithm trended hashtags that had negative connotations because people were talking about those hashtags. So the more a hashtag is used, of course, the more relevant it is and the more likely it is to trend. And people talking about hashtag never Warren or hashtag it's okay to be white caused them to trend, even though that wasn't what people were intending to do. And in this example, which was very recently discovered, someone found out that accounts on TikTok are actually recommended based on their profile picture and not the sort of content that they're being shared. So if I would, for instance, follow this account, this blonde woman account in the top row, and she's talking about something that interests me, like video games, it will actually recommend me other people with similar profile pictures, regardless of what they actually, what sort of content they actually share, and not the fact that they're sharing content about video games. Yeah, and this is maybe not something we want. And on the subject of recommendation algorithms, lots of studies have been done that show that recommendation algorithms actually create these radicalization pathways. And the reason for that is that, of course, you get into a filter bubble. If you watch a video about flat Earth, it's going to recommend you other videos about flat Earth, and it's also going to recommend you other videos that were watched by people who watch flat Earth videos. So they might recommend you stuff about anti-vaccination or climate disinformation or even racism, things like this. And yeah, so this recommendation system actually causes people to sort of go down these rabbit holes and become radicalized. This is the way they work. This is how they work, and this is sort of them working as intended. But this is perhaps not what we want. And if we think about the future of recommendation algorithms, right now they're very simple. But when they become more sophisticated, it's possible that they will actually try to optimize us. So they'll only show us content that they want us to see. They'll make sure that we interact with the users they want us to interact with. And if we post something that they don't want us to post, they'll share it with people who will dislike it. If we post something that they want us to post, they'll share it with people who like it or upvote it. And some of this somewhat already sounds familiar. So on to second part of this talk, which is about adversarial attacks against artificial intelligence systems. So why would we want to attack an artificial intelligence system? There are four main reasons. One is a privacy attack, where we're trying to expose data that was used to train the model. The second one is a poisoning attack, where we cause the model to start behaving the way we want it to. Third one is to craft an input that confuses the model into thinking that that input is actually something else. And the final reason would be to copy or reverse engineer someone else's model, to steal it if you want to start your own business based on something that someone's already done. Someone's already put the work in to gather data and train a model and so on. So how do we fool an AI algorithm? This is the third case that I just mentioned. And here we have a picture of a dog. So we feed it into a model, and it outputs a series of values. So here you see dog 0.9540, cat 0.0131, so on and so forth. Then what we do is we modify one or more pixels in the picture and then feed it into the model again and see what those new values are. And the idea is that we want one of the other values, let's, for instance, cat or bear, to be higher than dog. And once we've done that, the AI will then tell us that the picture is actually a cat and not a dog. And the way that this works in practice is like this. So on the left, we have a picture of a panda. And in the middle, we have this noise. And we apply this noise, but only 0.007 of this noise to the picture, which gives us the picture on the right, which looks identical to human as the picture on the left. They both look like pandas to us. But now that picture on the right is actually classified as gibbon. And this is a fairly easy attack path. And to illustrate how easy this is, all of the yellow bordered images in this diagram here are actually classified as airplane by an image classification algorithm. So it's actually really rather easy to fool or to create these inputs that actually fool the classifier. Why would we want to do this? Well, for instance, this is a very recent example where some researchers put a black sticker onto a speed limit sign, and it fooled self-driving cars, in this case Teslas, to think that the speed limit was 85 and not 35. And you can imagine other kind of attacks which could be achieved with paint, stickers, projecting of images, laser pointers, and so on. That could cause all kinds of problems, like not just misreading speed limit signs, but misreading other kind of traffic signs, or even, for instance, traffic lights. And you could cause traffic jams, or you could cause accidents and stuff like that. These types of attacks, which I've shown against image classifiers, also work against other types of things. Like in this case, a group of researchers in Germany managed to hide human spoken voice commands into an audio file of birds chirping. So the audio file, after the human spoken voice commands were embedded, still sounded to humans like just birds chirping. But in fact, AI was able to perceive those voice commands, and that would be your Siri or your Alexa or so on. And you could use this kind of methodology to create an attack. For instance, you could forge a leaked phone call depicting a plausible, scandalous interaction between politicians, get it on the news, and then when it's played on the news, suddenly, like households millions of households that have Alexas would receive those voice commands and order something from Amazon, unlock the door if it's a smart home, or for instance, instruct Siri to perform a web search for something like drugs or something bad. So I mean, there are lots of like potentially nasty situations that you could forge from doing something like this. Recommendation systems are probably the most widely attacked machine learning systems out there right now. Recommendation systems are everywhere. So you go on Amazon and you look at a book, it recommends you other books, and that's based on the fact that people who went and bought one book or added one book to their wish list or their shopping cart also added other books. And so it finds these similarities and generates these recommendations. And you find the same recommendations in YouTube when you watch a video, it recommends you other things, or in app stores, it recommends you other things when you've bought an app, or in social networks and who it's recommending you to follow. Or in fact, nowadays, your timeline in Twitter or Facebook will actually be curated based on a recommendation system. And how do we attack these? Well, this process is called a Sybil attack. And the way that it works is you create a large number of fake users or accounts, and then you have them engage with items or things in the system in order to change how that item is recommended. So if you want book B to be recommended when someone looks at book A, you get your fake accounts to visit both A and B, or add both A and B to their shopping cart or something like that. And then the system will slowly change. And this is a poisoning attack. So in the future, it will then recommend book B alongside book A, whereas it wouldn't have normally done that. And the nice thing is, You can actually find services online, really inexpensive services that allow you to do this. You can buy App Store reviews, you can buy retweets, followers, you can buy Facebook likes, you can buy YouTube views, subscribes, comments. You can even buy Google autocomplete. So you can, for instance, buy a Google autocomplete that when someone types your competitor's business name in, it will actually autocomplete it with something like scam or fraud, and then people will maybe not bother going to visit your competitor's website. Alongside all of these services, of course, you can also purchase fake accounts and run your own disinformation campaign. So buy the fake accounts, they're fairly inexpensive, set them up to look like how you want, buy retweets for them, publish your own content. And as it turns out, social networks don't do a whole lot about these fake accounts. So Stratcom Center of Excellence purchased almost 19,000 accounts and then reported them. And after 3 weeks, 95% of them were still active. So it's a good return on investment. However, if you can't be bothered to go through all of that, you can just pay a PR firm to do this for you. And there are PR firms in many countries now that offer the professional disinformation services. They'll set up the accounts, they'll do things that you ask, and they'll even do political disinformation for you. So now let's look at the third topic, which is possible malicious use of artificial intelligence. I've broken this topic into several subcategories. The first one is cybercrime. I'd just like to preface this by saying that, like, I've seen a lot of people fear that cyber attackers are already using AI. And we're, of course, a cybersecurity company, and we've not seen any AI-powered malware, and we don't have evidence that cyber attackers are using machine learning techniques. We haven't seen any evidence of yet. But what I'm going to present is some tools and techniques that are potentially useful for cyber attackers, and then speculate a little onto what they might do once they do start adopting AI. So here we have Emotet. Emotet is a malware that when it infects a system, it contacts a server, and it sends a little bit of information that it gathers from the system it infected to that server. The server then uses that information to decide which payloads the malware will then download and install. And it's been suggested that the Emotet server actually would utilize artificial intelligence to decide which additional software the infected system should download. However, we haven't really substantiated that claim. And to be perfectly honest, the information that gets sent up, there's only about 5 very simple pieces of information, and it would be quite possible to handwrite rules to determine what kind of software to send down. So it wouldn't necessarily require any kind of machine learning to do that. A group from Japan have developed a system called Deep Exploit that actually learns how to attack web servers or web application servers. And what it does is it queries a server, it gathers some information about it, it feeds it into the model, and then the model outputs a series of instructions on what sort of payloads to deliver to that server in order to hack it, in order to infect it. And it uses the same technique that was used to learn to play Atari games, Go, chess, these sorts of things. And it actually looks like a promising technique. Password generation has traditionally been done by handwritten algorithms. So when someone is trying to brute force a password, they'll use an algorithm that takes a list of already like very common passwords and sort of changes like A's for 4s and S's for 5s and these sorts of things in order to generate a list of passwords to try. And someone actually tried a machine learning approach to do this, and it's a similar approach to that machine learning, the type of machine learning model that generates these fake photos of people's faces, and it turned out to be better than any previous algorithmic methods. And also capture. So capture is this annoying thing that you sometimes come across on the internet where it's trying to prove that you're a human. In the old days, capture would show you a word. Over on the left, there's an example of that where you see the word overlooks an inquiry, and then you're meant to type that word in and it proves you're a human. Nowadays, you'll see more of these click the boxes where there's a car or something like that. But anyway, it's the same idea, that it's trying to prove, it's trying to do something that is very difficult to be done algorithmically. But nowadays, machine learning techniques are actually learning how to solve those. And the way that, for instance, social media accounts are created en masse is that there is a script that creates these accounts, but when it gets to the capture stage, it actually sends that capture image to a person, and that person has to then solve it quickly and send back the solution, and then the script takes that and then continues to create the account. But if you are able to do this completely automatically, then you wouldn't even need those people in the loop. So what would cyber criminals do once they start using machine learning techniques? Well, think about Cambridge Analytica, but think about it more for crime. So they could start profiling people and use that information, use data analysis techniques to do things like planning and executing phishing campaigns, gather analytics in order to do social engineering, scams, phishing, and so on social media, or even automate the activity of recon against a company, or to set up a targeted attack. And in the future, if we think about like a bit more long term, we might see like scams being automated via speech recognition and chat bots. We might see auto-conversational social media bots, swarm intelligent botnets, or actually intelligent malware, this AI-powered malware that people talk about. But again, this is actually quite far off. Onto the second subsection about this. What I'll talk about here is audio-visual content. And by now, most of us are aware of these generative adversarial networks that are able to generate images of people's faces, but they're actually not real people. They're fake people, and they're very realistic face pictures. As you can see, the technique has rapidly improved over the years. In fact, we don't have a picture for 2019 on this one yet, because the technique has gotten about as good as it's going to get. Almost, maybe. When I was writing the SHERPA document, I could only find one instance of an artificially generated face being used on social media, and it was this one. A sock puppet account was created specifically to target journalists. However, a year later, and this technique is being used all over social media. It's being used on Facebook, it's being used on Twitter, it's being used to generate accounts for political purposes, it's being used to generate accounts for harassment purposes, and also for phishing and targeted attacks. There's even one that was found on Finnish Twitter about a week ago. So in some cases, it's possible to spot that these fake images are actually fake. Couple of techniques here. On the left, one researcher took all the photos and superimposed them on top of each other, and you can see that the eyes and nose and mouth are roughly in the same place for all of these synthetically generated faces. On the right, you can see, for instance, some asymmetry in this this guy's glasses. And in fact, you can find these artifacts, unsymmetrical ears, and other kind of artifacts like missing bits of hair and things like this. But this is basically because the person who chose this picture was sloppy. He or she didn't look carefully at the picture to determine whether there were artifacts in it. And if you're careful about it, you can find those that don't have obvious artifacts in them. There are many machine learning techniques being developed for synthetically generating audiovisual content. And here's a couple of examples of image and video generation modification. Unfortunately, I don't have time to go through these, but as you can see, for instance, you can change horses into zebras. You can paint a picture and then have it rendered as an actual photograph. You can make someone's face act like someone else's, or someone generate a pose similar to what someone else was posing as, in this case, dancing. And in fact, on the audio side, there are services out there that are able to synthetically generate a voice similar to someone else's voice. And this opens up possibilities. For instance, if you want to generate a fake video and then add voice to it, you can add that person's voice who's in the fake video. Or, and this has already been done, you can use this kind of technique for CEO impersonation. So CEO impersonation works in a way that an attacker will call someone in the finance department pretending to be the CEO or some high-ranking person in the company, and tell them that there's an urgent business deal they're trying to get through. In order to do that, we need to move some money to this account, and it has to be done right now. It's normally followed up with an email of some sort, and the person might be tricked into moving the money. And of course, if you can synthesize the voice of that CEO, then that attack works much better. Deepfakes is something that is, of course, very familiar to most people nowadays. Deepfakes continues to improve, and it's basically a way of swapping someone's face with someone else's face in a video. Recently, there was a deepfakes posted of clips from Back to the Future with different actors' faces on them. That was apparently very impressive. The question is, are these techniques being used? Are these video techniques being used to affect politics? I could only find two mentions of speculation that deepfakes are being used in politics, but neither was proven. And I think what we'll find is actually that shallow fakes are still being used because they're very easy to create and they're very impactful. For instance, this video of Nancy Pelosi, which was slightly slowed down to make her sound drunk, was just a very simple technique. And in fact, I just read yesterday that a video, and this is a very common practice of taking clips of a politician out of context. So just taking a sound bite and sort of stringing them together, it makes them sound like they're talking about something other than what they were. And in fact, some video of Joe Biden yesterday was actually marked by Twitter as disinformation because of the way it was clipped together. Finally, let's look at some written content generation. So in 2017, the FCC ran a poll, and someone inserted over 1 million synthesized comments into this poll. And the comments were basically generated by taking a few sentences of text and then replacing words or phrases with synonyms. So if you look at this picture, you see this in green: Americans, individual citizens, people like me, citizens. So they essentially all of these clippings of text say the same thing. They just have words replaced with other words. And this is not machine learning. This was just generated by a tool like this one. This is a very cheap tool, really available on the internet, that can take some written content and spin it in the same way as these FCC comments. And it uses cloud-based thesaurus, and it can do 20 different languages. It's very fully featured. It can even post comments for you. Faked written content isn't just used for political purposes. I found this article from 2014 that detailed faked scientific papers that were synthesized and then submitted to journals. And in some cases, those were even passing the peer review process. So during the time that I was writing the document in 2019, early 2019, I speculated as to the idea of a sophisticated text synthesis model. And as I was writing the paper, OpenAI actually published this model that they trained called GPT-2, and it represented a drastic improvement over existing models of this type. In fact, it was so good that they chose not to release the trained model at that time for fear that people would misuse it. So they started making it available, firstly a small version, then a medium-sized version, and finally at the end of 2019 they released the full model. But then since then Google has created a vastly superior model. So this field of text synthesis continues to improve. I was wondering if these models are actually being used on social networks, and I found a couple of bots that reply to other accounts and probably use these more sophisticated text synthesis models. These are accounts that are for fun, and they're pretty cool. I wrote a Twitter thread about them, and they actually replied to me, and the reply itself was pretty impressive. However, there are some somewhat dubious or perhaps more malicious looking things that people are doing with text synthesis. For instance, this paper from last year from researchers in China was looking at how to synthesize replies to news content. So you go to a news site, you read an article, and then there's a comment section afterwards. And they took news articles and comments and trained a model to learn how to reply to reply in comment sections. And of course, you could use this to pre-populate some comments in a news section on a website, but it could also be used for malicious purposes, such as spam or disinformation. But again, shallow fakes are much easier to create than playing around with these text synthesis models. It's still fairly difficult to do that, and shallow fakes are also much more impactful than synthesized text. Here's two examples. On the left, we see a photoshopped tweet. So someone photoshopped a tweet to make it look like Jeremy Corbyn had tweeted something that he didn't, and they spread it around social media, and people believed it. And on the right, someone tweeted some completely made-up statistics, and it received over 3,000 retweets. So it got a lot of engagement, and nobody bothered to fact-check it. So just a few conclusions, things that we found from doing this report. In terms of bad AI, there are machine learning based public services that shouldn't exist, like the essay grading or the Twitter bot detection. And people, because AI is a complex topic, people might not understand why these things shouldn't exist, why these things don't work. And there is no mechanism to advise people on what they should or shouldn't be using. As we see, some AI systems are already being attacked. And of course, just like everything else, most of the time and effort spent learning to attack and defend systems is concentrated on those which are most widely used and widely attacked. So it's not to say that those which aren't being studied or which haven't been targeted aren't vulnerable. They are. And of course, as AI finds its way into more systems, the motivation to craft attacks against them will increase. Recommendation systems are a problem. They're optimized to drive engagement and revenue, and not protect people from things like mistruths, harassment, and manipulation. They're being weaponized, and the systems themselves are still fairly simple. These problems will get worse as these systems become more sophisticated, and we strongly advise regulatory action in this area. People should start to understand what these systems are doing to society. As mentioned, we don't see any evidence of machine learning techniques being used by cyber attackers, but there are lots of interesting tools out there for both attackers and defenders. In terms of audio-visual content, we now see some of these machine learning-based techniques being adopted, like the fake faces, like the synthesized voices, and we can imagine that as these techniques continue to improve, more of them will be taken into use. And finally, in terms of written content, even though these new models, these new text synthesis models are impressive, they won't write what you want. They're just not good enough to convey the message that you want. So written content designed for scams, social engineering, and disinformation are going to continue to be written by humans. And that's it. So let's get to questions.